CAT5 cable is not suitable for power transmission. It is designed for carrying data only. The maximum current rating for CAT5 cable is typically 0.5 amps, which is insufficient for powering multiple wireless access points. Running power through CAT5 cable can damage the cable and create a fire hazard. It is best to consider separate cables for power and data. Use plenum-rated cable for the power supply, with a wire size of number 18 or larger. This meets the Class 3 circuit requirements and provides adequate current capacity. Use CAT5E or higher for the data transmission. An alternative cable option is to consider using Power over Ethernet, abbreviated PoE, injectors. These devices send both power and data over a single Ethernet cable, eliminating the need for separate cables. In healthcare facilities, the use of plenum-rated cables is typically required for safety reasons. All electrical work should be performed by a qualified electrician. Always consult the manufacturer's specifications for specific guidelines on powering wireless access points. When dealing with electrical systems, especially in sensitive environments like hospitals, it's crucial to adhere to safety standards and regulations. Let's delve into the technical aspects and code requirements to ensure safe and compliant installation. Firstly, it's important to understand the limitations of CAT5 cable. While it can transmit data effectively, its small wire gauge makes it unsuitable for carrying significant electrical current. The typical wire gauge in CAT5 cable is 24 American wire gauge, abbreviated AWG, which has a limited current carrying capacity. Exceeding this capacity can lead to overheating, insulation damage, and potentially a fire hazard. Secondly, Class 3 circuits, as mentioned, have specific requirements for wire size and insulation. The National Electrical Code, abbreviated NEC, defines Class 3 circuits as power sources not exceeding 30 volts alternating current, abbreviated AC, or 60 volts direct current, abbreviated DC, with a power limitation of 100 volt amps. While the 48 volts direct current power supply falls within the voltage limit, the wire size must be adequate to handle the current without overheating. Number 18 American wire gauge is often cited as a minimum for Class 3 circuits, but it's crucial to verify this against the specific requirements of the NEC and any local amendments. The total amperage for all the wireless access points is 1.21 amps. To determine the appropriate wire size, you need to consider the ampacity, which is the current carrying capacity of the wire. The NEC provides tables, such as Table 310.15b16, that list the ampacity of different wire sizes based on insulation type and installation conditions. For example, a number 18 American wire gauge copper conductor with type THHN insulation installed in conduit typically has an ampacity of 14 amps. However, factors like ambient temperature and the number of conductors in a conduit can affect the ampacity. These factors require adjustments to the ampacity rating. If the adjusted ampacity is less than the load current, you must increase the wire size. Thirdly, the use of plenum-rated cables in healthcare facilities is a critical safety measure. Plenum spaces are areas above suspended ceilings or below raised floors that are used for air circulation. Ordinary cables, when burned, can release toxic fumes that can quickly spread throughout the building via the plenum. Plenum-rated cables are designed to resist the spread of flames and produce minimal smoke and toxic fumes, providing valuable time for evacuation in the event of a fire. Fourthly, Power over Ethernet, abbreviated PoE, is a viable alternative for powering wireless access points. PoE technology allows you to transmit both data and power over a single Ethernet cable, simplifying installation and reducing cable clutter. There are different PoE standards such as 802.3F, 802.3Et, and 802.3, each offering different power levels. It's essential to select a PoE standard that provides sufficient power for the wireless access points. PoE injectors can be used to add power to the Ethernet cable, or PoE switches can provide power directly to the connected devices. When using PoE, ensure that the cable is rated for PoE applications and that the connectors are properly installed to avoid power loss or damage. Fifthly, when running separate cables for power and data, proper installation practices are essential. Keep power cables and data cables separated to minimize electromagnetic interference, abbreviated EMI. This interference can disrupt data transmission and reduce network performance. Use separate conduits or cable trays for power and data cables, and maintain a minimum separation distance of several inches. Grounding is another important aspect of electrical safety. Ensure that all electrical equipment is properly grounded to prevent electrical shock hazards. The grounding system should comply with the requirements of the NEC Article 250. It is important to also consult the manufacturer's specifications for the wireless access points. The manufacturer will provide specific guidelines on power requirements, cable types, and installation procedures. Adhering to these guidelines will ensure optimal performance and prevent damage to the equipment. Furthermore, it's worth considering the long-term implications of the installation. Will the power requirements of the wireless access points increase in the future? Will additional wireless access points be added to the network? Planning for future expansion can prevent costly rework later on. Oversizing the power cables and using a PoE switch with sufficient power capacity can accommodate future growth. Another factor to consider is energy efficiency. Using energy-efficient wireless access points and power supplies can reduce operating costs and minimize the environmental impact. Look for devices that are ENERGY STAR certified. In summary, while CAT5 cable is not suitable for powering multiple wireless access points, there are several alternative solutions available. Using separate plenum-rated cables for power and CAT5E for data is a safe and reliable option. PoE technology offers a convenient way to transmit both power and data over a single cable. Regardless of the solution you choose, always adhere to safety standards, consult the NEC, and follow the manufacturer's specifications. Remember, electrical work should be performed by a qualified electrician who is familiar with local codes and regulations. In addition, ensure that all cables and equipment are properly labeled to facilitate maintenance and troubleshooting. Cable labels should clearly identify the purpose of each cable and its destination. This can save time and effort when performing future upgrades or repairs. Consider using a cable management system to organize the cables and prevent tangling. A well-organized cable infrastructure can improve airflow and reduce the risk of overheating. Regularly inspect the cable infrastructure for any signs of damage or wear. Damaged cable should be replaced immediately to prevent safety hazards and performance issues. Keep a record of all electrical work performed, including cable types, wire sizes, and circuit breaker ratings. This documentation can be invaluable for future maintenance and troubleshooting. By following these guidelines, you can ensure a safe, reliable, and compliant installation for the wireless access points in the hospital corridors. Remember that safety should always be the top priority when working with electrical systems, especially in healthcare facilities where patient safety is paramount. This is about mitigating risk and ensuring that the systems and installations meet the current and future demands. When planning the layout of the cables, consider accessibility for future maintenance. Ensure that cables are not obstructed by other equipment or building structures. Provide sufficient slack in the cables to allow for movement and adjustments. Use cable ties or Velcro straps to bundle cables together and prevent them from sagging or drooping. Consider the impact of the installation on the aesthetics of the hospital corridors. Conceal cables wherever possible to minimize visual clutter. Use cable trays or conduits to route cables neatly and discreetly. Coordinate with the hospital's facilities management team to ensure that the installation complies with their aesthetic standards. When selecting cable pathways, avoid areas where cables could be exposed to physical damage, such as doorways or high-traffic areas. Use protective measures, such as cable guards or conduit, to shield cables from potential hazards. Be aware of the potential for electromagnetic interference from nearby equipment, such as medical devices or radio transmitters. Shielded cables may be necessary to mitigate the effects of EMI. When terminating cables, use high-quality connectors and follow the manufacturer's instructions carefully. Properly terminated cables will ensure reliable performance and prevent signal loss. Test all cable connections after installation to verify that they are working correctly. Use a cable tester to check for continuity, shorts, and other faults. Document the test results for future reference. Provide training to hospital staff on the proper use of the wireless access points and the importance of not tampering with the cable infrastructure. Educate staff on the potential hazards of overloading circuits or damaging cables. Establish a regular maintenance schedule for the wireless access point system. This should include inspections of the cables, connectors, and power supplies. Replace any worn or damaged components promptly. Keep a supply of spare parts on hand to minimize downtime in the event of a failure. By implementing these best practices, you can ensure that the wireless access point system operates safely, reliably, and efficiently for years to come. Consider the specific needs of the hospital environment. Healthcare facilities often have unique requirements for infection control, patient privacy, and security. Ensure that the installation complies with these requirements. Work closely with the hospital's IT department to integrate the wireless access point system into the existing network infrastructure. Ensure that the system is compatible with the hospital's security protocols and data management policies. Be mindful of the impact of the installation on patients and staff. Minimize noise and disruption during the installation process. Schedule work during off-peak IOs whenever possible. Communicate clearly with hospital staff about the scope and duration of the installation. By taking these factors into account, you can ensure smooth and successful installation that meets the needs of the hospital community. Remember that the goal is to provide reliable wireless connectivity while maintaining a safe and comfortable environment for patients and staff. In healthcare environments, robust wireless infrastructure is essential for supporting critical applications such as electronic health records, patient monitoring, and telemedicine. Therefore, careful planning and execution are crucial to ensure a successful deployment. Ensure that the wireless access points are properly configured to provide adequate coverage throughout the hospital corridors. Perform a site survey to identify areas with weak signal strength and adjust the access point placement accordingly. Optimize the wireless network settings to minimize interference and maximize performance. Use appropriate security protocols to protect patient data and prevent unauthorized access to the network. Implement a robust monitoring system to detect and respond to any network issues promptly. Provide ongoing support and maintenance to ensure that the wireless access point system continues to operate reliably. By following these guidelines, you can create a wireless network that supports the delivery of high-quality healthcare services in the hospital. Remember that a well-designed and maintained wireless network can improve patient outcomes, enhance staff productivity, and reduce operational costs. Also, bear in mind the evolving landscape of wireless technology. Stay informed about the latest advancements in wireless standards, security protocols, and network management tools. Regularly evaluate the performance of the wireless access point system and make adjustments as needed to optimize its performance. Consider upgrading the system periodically to take advantage of new features and capabilities. By staying ahead of the curve, you can ensure that the hospital's wireless network remains state-of-the-art and continues to meet the evolving needs of the healthcare community. In conclusion, powering wireless access points effectively and safely requires a comprehensive approach that considers factors such as cable type, power requirements, safety standards, and network performance. By following the recommendations outlined above, you can create a robust and reliable wireless infrastructure that supports the delivery of high-quality healthcare services in the hospital. Remember that safety should always be the top priority when working with electrical systems, and that qualified professionals should be consulted for any electrical work. Also, it is worth looking at local Texas requirements that are specific to your location, as many locations have different codes.